Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at the nature of roots for mathematics grade 11, a topic many find extremely confusing and difficult, but this video aims to simplify all that complicated maths for you. On that note, please don't forget to click the subscribe button and hit the notification bell so you don't miss out on new videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Now back to the video. In detail, we're going to look at the quadratic function, an equation, in its most basic standard form, the very same form you started learning about quadratic equations from in grade 9, and that is f of x equals to ax squared plus bx plus c. You can also use y equals to ax squared plus bx plus c. It means exactly the same thing. Number 2, we're going to look at the quadratic formula, which is one of three ways of solving for the roots of the quadratic equation. The first being factorization, and the second being completing the square, and the third one, now the quadratic formula. We're going to look at why this formula is important and why it is the simplest we can use as a method to solve for the roots. Number 3, the discriminant, which is part of the formula, and that is the part that it says b squared minus 4ac, and we'll see why that is the most important part of the formula, because basically that's what helps us determine the nature of roots without having to go through all the trouble of solving for the roots of the equation. Number 4, we're going to look at the graphical illustration of the nature of the roots, just to show you a visual of what the roots would look like if you were to plot the graph without having to solve for the equation. Number 5, we're going to look at examples that will help illustrate all the lessons that we learn in this video. We have a lot to cover, so let's start. Step number 1, let's revise the standard form of the quadratic equation, that is f of x equals to ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is simply the constant. Now remember a, b, and c because they're important in the discriminant and determining what the discriminant is like, which in turn helps us determine the nature of roots. Now the formula is x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. This is the formula we use to find the roots of the equation without having to factorize or complete the square, which makes life so much easier. Now the discriminant is this part under the square root sign that helps us determine the nature of roots without having to solve the equation. That's why it's important, and you will see exactly how that happens. How do you determine whether the roots are real or unreal? How do you determine whether they're equal or they will be equal or unequal? Whatever the case may be, we're going to look at that. Now, let's do that. Now, here is a diagram that helps us map out what the nature of the roots is going to be like. We'll take it from step 1. Now, step by step, this is how you decide and determine the nature of roots. Step number 1, you decide whether the roots are real or imaginary. Now, before you can do all that, you need to know what your A, your B, and your C are, so that you can chuck them into this discriminant formula. So you find your A, B, and C from the equation after you make it in a standard format, and then you calculate b squared minus 4ac, which is the discriminant. Now, if your discriminant is negative, then it means your roots are imaginary or non-real. And if your discriminant is either 0 or a positive number bigger than 0, then that means you are dealing with real roots. That's step number 1. Imaginary, discriminant negative. Real roots, discriminant 0 or positive. Now, step number 2. After you determine that your roots are real, and if your roots are real, in other words, your discriminant is either 0 or a number bigger than 0, then you can take it a step further. However, if your roots are imaginary, in other words, your discriminant is negative, that's where it stops. No need to go further. You cannot go any further than that. That's what you do. That's your answer. Your roots are imaginary or non-real. Now, what happens when your roots are real? In other words, your discriminant is either 0 or bigger than 0. A positive number. Then you take it a step further. You determine whether these real roots are equal or unequal. The roots will be equal if your discriminant is equals to 0. Exactly. But if your discriminant is bigger than 0, in other words, a positive number, then your roots are unequal. That's step number 2. Step number 3, after determining whether your roots are equal or unequal, the real roots. Now you take it a step further. If your roots are equal, in other words, the discriminant is equals to 0, then that's where it ends. There's no taking anything further. Your roots are real and equal, that's it. Now, if your roots are real and unequal, in other words, your discriminant is greater than 0, it is a positive number, then you take it a step further. That is step number 3. You decide whether these unequal roots are rational or irrational. And how do we do that? If your roots are rational, then your discriminant will be a perfect square. Now that perfect square can be a whole number or it can be a rational number. A rational number is any number that you can write as A over B. In other words, an integer over another integer. Now if you need to remind yourself or a refresher on what the real number system looks like and how rational numbers fit into the real number system or the number system for that matter, there's a video I did on the channel that is the number system for grade 10 and 11. Go watch that video. I'm going to put it on the description box as a link so that you can easily click and go to that video. Now let's continue. Now if your roots are irrational, your discriminant will be a positive number bigger than 0 but will not necessarily be a perfect square. It will not be a perfect square. So how do you know your roots are irrational? When your discriminant is a positive number but not a perfect square. And you know your roots are rational when your discriminant is a positive number bigger than 0 and it is a perfect square. That's how you know. Now before we look at examples to help us illustrate this, let's look at a visual representation of how this roots would look if you were to plot the graph without having to solve the equation. Now if you discover that your roots are non-real or imaginary, in other words, your discriminant is negative, then this is what the roots are, the graph is going to look like. Sorry about that. Now, it does not matter whether the arms look up or down. Remember, the arms will look up if your A is positive, the coefficient of x squared, but if your A is negative, then your arms will look down. It does not matter whether your arms look up or down. If your roots are non-real, the graph will not touch the x-axis. It will just hang up there or down there. Now, if your roots are real, in other words, your discriminant is either greater than 0 or 0, then you will have at least one root. You will have exactly one root, or the graph will touch only at one place by the turning point, whether the arms look up or down, if your roots are real and equal. In other words, your discriminant is equals to 0. This is the situation you're going to get. Depending on whether your A is positive or your A is negative, the arms will look up if A is positive and the arms will look down if A is negative, but it will only touch only one place on the x-axis. Now, if your roots are real and unequal, in other words, your discriminant is any number greater than 0, then your graph will cut the x-axis at the maximum 2 points. In other words, it will have a maximum of 2 roots that you can have in a parabola. Whether the arms look up or down, you will have that situation where you've got 2 roots, or in other words, the graph cuts the x-axis at a maximum of 2 places on that set of axes. Now let's look at some examples to help us illustrate all the notions that we've just learned. Example 1 says, show that the roots of x squared minus 2x minus 7 is equals to 0 are irrational. Very important key, irrational. Now, according to the diagram, let's go back to that. When are roots irrational? Let's go back. According to this, roots are irrational when your delta is a number bigger than 0, but it's not a perfect square. Let's go back. So let's find out what the discriminant looks like, and then figure out if that number is a perfect square or not. But first, let's see if the equation we have is in standard format. Yes, it's in standard format. That's ax squared minus bx, ax squared plus bx plus c. Standard format, yes. Now, let's figure out what a is. A equals to 1, that is the coefficient of x squared, and b equals to the coefficient of x, which is negative 2. Please make sure that you also indicate the sum of the coefficients, and then c equals to negative 7 according to this equation. And now we know that for roots to be irrational, the discriminant must be a positive number greater than 0, but not necessarily a perfect square. So now let's find out what the discriminant looks like. The discriminant is equals to b squared minus 4ac, which is equals to b is negative 2, that's negative 2 squared minus 4 in bracket. A is 1 and c is negative 7. Make sure you use your brackets, very important, so you know who's who in the zoo, and you calculate your numbers correctly. Negative 2 all squared, that's 4. Negative 4 times negative 7 will give us positive 7. So that is, positive 28, that's plus 28 times 1. That is equals to 32. Now 32 is a number bigger than 0. It is a positive number bigger than 0, and it is not a perfect square. Therefore, the discriminant, you don't have to write an essay like this, is greater than 0, but not a perfect square. It's not a perfect square. Therefore, the roots are real, yes, unequal, and irrational. And that's how you solve that thing. Next question. For which value of k will the roots of 6x squared plus 6 equals to 4kx be real and equal? Now, when are roots real and equal? Let's go back to the diagram. Roots are real and equal when the discriminant is equal to 0. Yeah, they are real and equal when the discriminant is equal to 0. So what we need to do is find the discriminant and equate it to 0 and solve for k. Now, before we do that, let's figure out if this equation is in standard format. No, it's not, so we need to make sure that it is in standard format so we can decide and determine what our a, b, and c are. So let's go. Therefore, 6x squared plus 6 minus 4kx, take everything to the left-hand side, equals to 0. Now, therefore, let's put it in standard format. Cx squared minus 4kx plus c equals to 0. Now it is in standard format, and that standard format is ax squared plus bx plus c. Now we can figure out what our a is. Our a equals to 6, our b equals to negative 4k, and our c is equals to 6. Now, for roots to be real and equal, for real and equal roots, delta, the discriminant, which is supposed to be squared minus 4ac, must be greater than or equal to 0. Now let's find what b squared minus 4ac is. So therefore, b squared, which is b is equals to negative 4k, there it is, negative 4k, negative 4k, negative 4k, all squared, minus 4. A is 6, and C is 6. 6 times 6. All this must be greater than or equals to 0 for roots to be real and equal. For roots to be real and equal. Sorry, for roots to be real and equal, the discriminant must be equal to 0, not greater than or equals to. Must be equal to 0. Sorry about that. Let me fix that. Must be equal to 0. Now we solve. Therefore, minus 4k all squared, that is 16k squared, minus 4 times 6 times 6, 4 times 6 times 6, that is equals to 144, equals to 0. Now if you notice, this is a difference of 2 squares. If you need help with factorization of the difference of 2 squares, I did a whole video on grade 10 factorization that covers all types of different methods of factorization, and this is one of them. So we go 2 pairs of brackets, then you put the square root of the first term, which is the square root of 16 is 4. The square root of k squared is k, so that's 4k. You put that on the first terms of each bracket. Now on the second terms, you put the square root of the second term, which is 12 in this case. In one you put negative, and in the other you put plus. Doesn't matter which bracket you put plus and which you put negative, it does not really matter. But the point is, one must be negative and the other must be positive. And now you solve as you would any other normal equation. Therefore, 4k minus 12 equals to 0, or 4k plus 12 equals to 0. I do not recommend skipping this step because that's where a lot of people make silly mistakes. 4k equals to 12, or 4k equals to negative 12. Now, in order to find k, you divide both sides by 4. Therefore, 4k divided by 4, 4k divided by 4 is equals to 12. Let me fix that. 4k divided by 4, 4k divided by 4 equals to 12 over 4, or 4k over 4 equals to negative 12 over 4. Therefore, k here is equals to 3, or k equals to negative 3. The question was, always go back to the question to verify what you're answering. For which values of k will the roots of 6x squared plus 6 equals to 4kx be real and equal? All right, now let's answer. Therefore, the roots will be real and equal if k is equals to 3 or k equals to negative 3. You can simply write it as if k is equals to plus or minus 3. That is a shortcut way of doing it. It's exactly the same thing. Next question. The equation x squared plus 12x equals to 3kx squared plus 2 has real roots. We are told it has real roots. And what is the condition for having real roots? That is when your discriminant is greater than or equal to 0. Yes, according to the diagram. You can go back to that just to verify for you. When are roots real, that's when your discriminant is greater than or equals to 0. There we go. Find the greatest value of k such that k is an element of integers. The equation has real roots. Find the greatest value of k such that your k is an element of real numbers. Integers. This means integers. Now, integers are whole numbers, which include negative numbers and 0 in the middle, but they are whole numbers. So now how do we do that? First, we figure out what the discriminant is. And before we can do that, we rearrange this equation in standard format. So we go, therefore, x squared plus 12x minus 3kx squared, take everything to the left-hand side, minus 2 equals to 0. Therefore, let's put all the x squared together, x squared and minus 3kx squared, so that is 1 minus 3k, all have x squared, then plus 12x minus 2. Now that our equation is in standard format, ax squared plus bx plus c, we can figure out what our a is. Our a is 1 minus 3k, our b is equals to 12, and our c is a constant, which is negative 2. They say the equation has real roots. Then find the greatest value of k such that. Now we know that for real roots, delta, which is the discriminant, must be greater than or equals to 0. Therefore, we find b squared minus 4ac is greater than or equals to 0, meaning that b is equals to 12. So that is 12 squared minus 4. A is 1 minus 3k, and c is negative 2. 1 minus 3k, and c is negative 2. That must be greater than or equals to 0. Therefore, 12 squared is 144. And now let's multiply negative 4 by negative 2, which gives us 8, plus 8 in bracket, 1 minus 3k, which is greater than or equal to 0. Now that is 144 plus 8, 144 plus 8. Take out a calculator. Don't try to add this. That's where many people make silly mistakes. 144 plus 8, that is 152. 152 plus, so that is, let's expand this first. So that's 144. Then when we expand this, that is 8 times 1. So that is plus 8. And that is 8 times negative 3k, that is minus 24k. This is greater than or equals to 0. Therefore, 144 plus 8, that is 152, minus 24k is greater than or equals to 0. And now you take the 152 to the right-hand side. So that is negative 24k is greater than or equals to negative 152. Now, what happens to an inequalities? If you divide through by a negative number, you change the sign in the middle. You change this. This changes from greater than or equals to negative to less than and equal to. And you will see exactly what that means. So you divide both sides by negative 4. Okay, that is greater than or equal to negative 24. Negative 152 divided by negative 24. Therefore, this will give you your k, and the k now will be less than or equal to and no longer greater than or equal to. That is the rule of, change back to the color, that is the rule of inequalities. So that is equals to 152 divided by negative 152 divided by negative 24. That gives us positive 19 over 3. That gives us positive 19 over 3. This is a tad bit dark. Okay, let's reduce the darkness a little. Alright, that is equals to, therefore, that is k is less than or equal to, 19 over 3. 3 goes into 19, 18, actually 6 times, and leaves a remainder of 1. 6 times and leaves a remainder of 1 over 3. Now the question was, let's go back to the question. The question was, find the greatest value of k such that k is an integer and that has real roots. Now this k is not an integer, it's a fraction. So the greatest value of k that is an integer will definitely be 6. Therefore, the greatest value of k is 6. And that's your answer there. Next, number B. The question is, find one rational value of k for which the above equation has rational roots. Now, when do roots become rational? That's when we have a perfect square. Let's go back to the diagram. Roots are rational when we have your discriminant is a perfect square. Rational roots. Now let's go back to the question. The question is, find one rational value of k for which the above equation has rational roots. For this to have rational roots, that means our discriminant, which is 144 plus 8 in bracket 1 minus 3k, right, must be a perfect square. For rational roots, the discriminant must be a perfect square. Meaning that therefore our discriminant, which is equals to 144, we've already calculated that, times 8 minus 1 over 3k, must be a perfect square. Perfect square. Now for that to happen, all right, it means that since 144 is already a perfect square bit of this discriminant, that means for that to happen, we will need the 8 times 1 minus 3k to be 0. Therefore, for the whole discriminant to be a perfect square, therefore, 8 times 1 minus 3k must be equal to 0. Now let's solve. Therefore, 1 minus 3k, divide both sides by 8 equals to 0. Therefore, take the 3k to the right hand side. Therefore, divide both sides by 3. Therefore, k equals to 1 over 3. Meaning that, therefore, for roots to be rational, k must be 1 over 3. And that's how you answer that question. Next question. Show that the roots of x plus h in bracket times x plus k is equals to 4d squared are real values for all real values of h, k, and d. When are roots real? According to the diagram, roots are real when your delta is greater than or equal to 0. Right, roots are real for or when the discriminant is greater than or equals to 0. Now, before we figure out what the discriminant in this case is, let's rearrange this equation in standard format. All right, so therefore, x plus h times x plus k, that will be equals to x times x, that's x squared, x times k, that is kx, h times x, that is hx, plus h times k, that is hk. Therefore, that is equals to x squared plus kx plus hx plus hk equals to 4d squared. Take everything to the left hand side, therefore x squared plus kx plus hx plus hk minus 4d squared is equals to 0. Now therefore, let's take this out of the way. Therefore, now let's arrange all the x squareds together, x's together, and constants together. X squared goes alone, so that is x squared. And then the x's are kx and hx. So that is plus k plus h x. And the constants are hk minus 4d squared. You can put them in a bracket just to help you see what they are. Therefore, now our a equals to 1, our b equals to k plus h, and our c, the constant, equals to hk minus 4d squared. Now let's find what the discriminant is. Therefore, b squared minus 4ac is equals to, our b is k plus h all squared minus 4, a is 1, c is hk minus 4d squared, hk minus 4d squared. So let's calculate that. K plus h all squared, let's square the binomial, that's k squared, plus 2 times k times h plus h squared. The last one squared, so that's k squared plus 2k to hk plus h squared minus 4hk plus negative 4 times negative 4d squared, that is equals to positive 16, negative times negative positive, 4 times 4, 16, that's positive 16d squared. So that is plus 16d squared. Take this out of the way, that is equals to, right, let's add like terms. Let's see if there are any like terms. 2hk and negative 4hk. 2hk and negative 4hk. These are like terms. 2hk minus 4hk. That is the same as 2 minus 4. 2 minus 4 is equal to negative 2, so that is negative 2 HK. So that is equal to, let's take it back. So that is negative 2 HK. Negative 2 HK. Let's take the color back. Negative 2 HK. Then we start with K squared minus 2HK and then plus 16D squared plus H squared, sorry. Let's not forget the H squared plus H squared plus 16D squared. This can be a little messy, just keep your concentration at its peak. And that is equals to, now if you notice this, K squared minus 2HK plus H squared is actually a square of a binomial, and this is K and K, H and H, minus and minus. K minus H times K minus H will give us this. K squared, let's show you that. Okay, let's multiply it back together. That's K squared minus KH minus KH plus H squared. Now add this together, they give you K squared minus 2HK plus H squared. I hope I've managed to convince you there. And that's how we factorize that. That is minus H. Okay, that is therefore plus 16D squared. That can be written as, this is a square of a binomial, can be written as K minus H, and you will see why that is important, all squared plus 16D can be written as 4D all squared, 16D squared. All right, now if you notice something, K minus H all squared will always be positive, regardless of whether this inside, when you add your K's together and H, become negative or positive. Same story here. It does not matter whether your D is positive or negative, it will always be positive. Now let's put that in words. K minus H squared, K minus H all squared will always be positive or 0. In other words, get greater than or equals to 0 for all real values of K and H. Also, D squared, 4D squared, 4D all squared. Also, let's not waste space. Also, 4D all squared will always be positive for all real values of D. Of D. Therefore, the sum of these two squares will always be positive. Will always be 0. Will always be greater than or equal to 0. Therefore, meaning that therefore K minus H all squared plus 4 in D all squared will always be greater than or equals to 0, making your roots, making your discriminant positive. Therefore, the discriminant will be positive, meaning that roots are real or will K, H, and D. That's how we prove that. Let's go back to the question, just for you to. Question was, show that the roots of this are real for all real values of HK. And we've shown it. Our discriminant will always be positive, and that's how you show the roots are going to be always real. Number 4, given x squared plus bx minus 2 plus k in bracket, x squared plus 3x plus 2 is equals to 0. Show that the discriminant is given by k squared plus 6bk plus b squared plus 8. So step number 1 here, you multiply out and put this, rearrange this into standard format. So let's go. That's x squared, number A, x squared plus bx minus 2 plus kx squared plus 3kx plus 2k is equal to 0. Now put all x squared together. So we've got x squared and kx squared. So that is 1 plus k x squared. X's, that's bx and 3kx. So that is b plus 3k. All have x. And then the constant is 2k minus 2. Let's put it in brackets so you can see exactly what it is. Now, therefore, our A is equals to 1 plus k. Our B equals to b plus 3k. And our C is equals to 2k minus 2. Now, let's substitute that into the discriminant. Delta is equals to b squared minus 4ac, which is equals to b plus 3k all squared minus 4. A is 1 plus k. C is 2k minus 2. B plus 3k all squared, that is the square of the binomial, that is equals to the square of the first term b squared plus 2 times the product of the two, 3bk, so that becomes 6bk, plus the square of 3k, that is 9k squared, minus 4. Now 1 plus k times 2k minus 2, 1 plus k times 2k minus 2, 1 times 2k, that is equals to 2k, 1 times negative 2, that's negative 2k times 2k, that is 2k squared, k times negative 2, that is negative 2k. Now let's add like times 2k minus 2k, cancel out and you get 2k squared minus 2. That's your answer. That's what you start with. So that's 2k squared minus 2. Now, this is equals to, let's remove this. This is equals to, b squared plus 6bk plus 9k squared, b squared plus 6bk plus k squared, 9k squared plus 9k squared minus 8k squared minus 8k squared, and then the last one plus 8. That gives us plus 8. That is equals to, okay, now notice that we've got like terms. Let's highlight all the like terms. That's 9k squared minus 8k squared. 9 minus 8 is equals to 1. So that gives us 1k squared. So that's k squared. Let's start with that. K squared So that will be k squared. Let's go back to the color. So that is k squared plus b squared plus 6b squared bk min plus 8. Now let's see if we've rearranged it the way. So that's k squared plus 6bk plus b squared plus 8, which can be rearranged like that. So which is equals to k squared plus 6bk plus b squared plus 8. And we have proven that. Number B says, if b is equals to 0, discuss the nature of the roots of the equation. All right. If b equals to 0, therefore, this is the situation. The discriminant is k squared plus 60k plus 0 squared plus 8, which is equals to k squared. This is 0 and that is 0 plus 8. What is the nature of roots? K squared plus 8. Now k squared will also always be positive for all real values of k. Be continued. K squared, the discriminant. Discriminant will be k squared plus 8. Okay, k squared will always be positive for all real values of k. Therefore, k squared plus 8 will always be positive. Be positive for all real values of k, for all real k's. Meaning that therefore, the discriminant k squared plus 8 will always be greater than equals to 0, meaning that roots are real and equal but we can never be sure if they are rational or irrational. And rational or irrational depending on your k, depending on the exact value of k, depending on the exact value of k, on exact value of k. So that value of k can make the whole thing a perfect square, which makes the roots rational, or it can make it an imperfect square, which will make the roots irrational. Number C. And this comes from the IEB paper of November 2001, higher grade, which is a paper that we used to write in mathematics for higher level of mathematics, which is now called just pure mathematics. If b is equals to 2, find the values of k for which the roots are equal. If b equals to 2, if b equals to 2, the discriminant delta will be equals to k squared plus 6 2k plus 2 squared plus 8. Let's go back to that discriminant. There it is. So that will be 2 and 2 squared. All right. So, and that is equals to, which is equals to k squared plus 12k plus 4 plus 8, which is equals to k squared plus 12k plus 12. Now for it to be equal, then that means we need to equate the discriminant to 0 for equal roots. The discriminant must be equal to 0, meaning that therefore k squared plus 12k plus 12 must be equal to 0, and now we solve. Let's use the formula to solve this. Therefore, k equals to minus b plus or minus square root of b squared minus 4ac all over 2a. That is equals to the negative b is 12 minus 12 plus or minus square root of 12 squared minus 4. A is 1. A is 1 and C is 12. A is 1 and C is 12. All over 2 times 1, which is equals to negative 12 plus or minus square root of, okay, 12 squared, that's 144, minus 4 times 12, 4 times 12, 4 times 12, that is equals to 48. All over 2, which is equals to negative 12 plus or minus the square root of 144 minus 48 minus 48, that is equals to 96. Square root of 96 over 2, which is equals to negative 12 minus 12. Okay. Common fractions button, negative 12 plus square root of 96. Down button 2. That gives us negative 6 plus square root of 6 plus 2 root 6. Negative 6, that is equals to negative 6 plus 2 root 6 plus 2 square root of 6, or the other root is, okay, fraction button, minus 12 minus square root of 96, down arrow 2, and that gives us negative 6 minus 2 root 2. Therefore, for roots to be equal, let's go back to the question. Therefore, for roots to be equal, therefore, for roots to be equal, for roots to be equal, for roots to be equal, k must be equal to minus 6 plus 2 root 6, or minus 6 minus 2 root 6. can write this as minus 6 plus or minus 2 root 6. And that is the answer to the question. We've come to the end of this video. Thank you for watching and see you in the next video. Bye.